Okay, let's illustrate how we would calculate the coefficient of variation when we're given probabilities. So in this example, we're taking a look at the situation where there's a 30% chance that the cash flow will be $20, 40% chance that it'll be $40, and a 30% chance that it'll be $60. Now, the formula we use to calculate the coefficient of variation is the standard deviation divided by the mean. And with probabilities, we've got to calculate the mean or the expected value. Okay, so let's illustrate. How do we calculate the expected value? Well, what we do is we take the sum of the cash flow times the probability. Now, in our case, we're using D to represent the discrete value we're interested in. Okay, so it's D is the cash flow or the outcome, P is the probability. So if we put this little table together, let me slide up here so you can see more of it. Slide up one more time. You can see what we do is we take the cash flows given times the probabilities given, multiply them, right? Sum of D times P, and then the sum is where we add them. So 6 plus 16 plus 18 is 40, so that becomes our expected value, or you can think of it as the mean, what we expect given this range of probabilities. Get rid of this. Okay, so what's our next step? We compute the standard deviation. Now to do that, we've got this extended calculation that we've got to follow here. Okay, so we have our cash flow and we have the mean that we calculated. We calculate the difference. Then we square the difference. So if that was negative 20 times negative 20 taken times itself, right, raised to the power of 2, negative 20 times 20. Well, negative 20 times negative 20 always will give us a positive value. So we have 400, then 0, then 400. I think that 0 there is a typo. I think that should be 40, giving us 0 here. Okay? And when we take all of these after we've squared them, multiplied them times themselves, we then have to multiply times the probability. Okay, we've got to go back to that. So 400 times 30% is 120. We come up with those values. We sum it. And we have 240. So then we apply the standard deviation, where we take the square root of the sum of D minus D, that's 240, and we get 15.5. And then our final step is to divide the standard deviation by the expected value. So 15.5 divided by 40, right? We calculated 15.5. The expected value of 40 we computed way up top here, right? Right there. Expected value. And when we do that, we've reached the final answer, which is 0.3875 or 38.75%. Okay, now what I want to do is show you how to solve this in Excel. Let me slide on down where I've worked this ahead of time. Okay, so here's the cash flows, right? 20, 40, and 60, that was given, and the probabilities. Now the three probabilities should sum to 100%, right? Since this is a decision tree, they should always sum to 100%. So then we can compute the expected values. Just take the cash flow times the probability for each one of these, right? And then we sum those, and that's our expected value. I also consider that to be the mean, all right? And then you calculate the deviation from the mean. So now we take the cash flow minus the 40 in every case. Okay, the cash flow minus the 40. And here we're proving that that one number above was a mistyped number. Okay, cash flow times the 40. Now we have to square the deviation. So take the deviation and raise it to the power of 2. One way you can do that in Excel is use that caret command. So you see it says take the value in E51, caret 2. That raises it to a power of 2. All right, now let me show you how you could also use the power function. Instead of just hitting F2, or instead of entering it as the cell E51 raised to the power of 2, you could also use the power function. I'll demonstrate it here. We could say equal power, let's spell it right, left parenthesis, and then it says it's looking for the number and the power. Now I'll come up here to the insert function so that we have this little pop-up. Just show it over here so we can still see where we're at. So where's the number? The number is right there. And the power we're raising it to is 2. So you could also enter it that way, right? Both of those ways will work. Okay, so now that we have the squared deviation, then what we just have to do is multiply the probabilities times the squared deviation. So we do that here, copy it down. You'll see I'm doing the same thing in all of these cells. And when we sum that, what we actually get, right, this is just the sum, that's now the variance. Okay, and our formula is take the standard deviation, the formula for the variance is take the standard deviation divided by the mean. So I'm not even sure we need that 240, but wanted to show that. Okay, the standard deviation. Well, actually, we do need this. We need the variance to calculate the standard deviation. So I'm using Excel standard deviation function. In the standard deviation is simply the square root of the variance. So the probability times the standard times the squared deviation gives us the variance, and then we have to take the square root of it. Now, again, Excel gives us a couple options. You can use the equal square root function. Okay, so what does this say? Just give me the number and it'll calculate the square root. Now you could do it that way, or you could say give it the number and raise it to a power of 1/2, which is 0.5. Or you could enter it as 1 divided by 2. Both of those will work. Okay, put it back to what it was, square root, and I'll show the other way. It's a little Excel trickery, right? Raised to the power of 0.5. All gives you the same number. Okay, and then when we divide the standard deviation by the expected value, we're able to calculate the coefficient of variation, and you see it's exactly the same, 38.75. Now, what I do want to point out is a lot of these extra characters are meaningless. So I would think, 4 decimal places should be plenty. Okay, so that's an illustration of how to solve this in Excel.